Okay, so this section is 5-6, which is about the remainder and factor theorems, which basically allow us to use synthetic substitution or synthetic division and extending that idea to help us evaluate polynomials in a much faster way than plugging in and doing all the math. So it's kind of neat because we can save some work this way. So something that I would add, hopefully my text will work here. If it'll allow me to put in some text. So you maybe can evaluate a polynomial for the letter A. We're going to use A as the value of the factor by using synthetic division, and I'm going to put that in quotes because we're not actually thinking of it exactly like synthetic division because we're going to use it to evaluate, but for which the remainder is the value f of A. Oh my. Okay. So basically, they give us a polynomial. They say evaluate f at some number. Say it's 2. You can use 2 where we would have put it in as a factor when we were doing synthetic division, and follow the process, and when you're done, the piece in the remainder section will be the value of f of x at that value, at A, which we said was 2 in that hypothetical situation. The factor theorem, and one of the things that you may or may not have seen before, is this. The factor theorem says that x minus a, which we've used before, x minus whatever number, if we divide into it, is a factor of the polynomial IFF. What that means, this is a shorthand that we use in higher level mathematics, theories, proofs. You probably used it in geometry proofs maybe, but this means if and only if. So this is a factor if and only if when I plug in A to F, my remainder is 0. So if I plug in A for some value of x, y is 0, which we've used that many times before. Okay, so what does this look like? Let me see. So if I am going to evaluate f of -5, it will look like this. Actually, I'm just going to put -5 here, and I'm going to put my little square in there here in a second. But if I put in my coefficients, so 2, -8, -2, and 5, and be sure, note to you, remember to check if all terms are present. Here we have a cube, a square, a regular x, and a constant, so we're good to go. Okay, so let's do our synthetic division, and I'm going to do this freehand. Hopefully it comes out okay. So I'm going to bring down my 2. Actually, I'm also going to put in a line right here because I want to know what happens in this section. I really want to highlight that. So back to doing our synthetic substitution is what we want to call it. No longer synthetic division, synthetic substitution. So bring down my 2, just like I always did. 5 times 2 is -10. Then this becomes -18. 5 times negative 18 gives me 90. And so when I add negative 2 and 90, I get 88. And then that times negative 5 is negative 440. And add again, and I get negative 435. So what this says is that I have just determined that f of negative 5 is negative 435. Okay, that's your solution. Much faster than trying to plug negative 5 in here, getting it in your calculator. At least when you get the process down, it's going to be much faster. Also, I forgot to draw in my little box. Okay, so let's also evaluate f of 2. So if I put in my 2, uh-oh, my 2 went away. There we go. If I put in my 2 and I get same coefficients, 2, negative 8, negative 2, and 5. And, oops, I did not want negative 2, or 22 there. Okay, same thing. Do your synthetic division. Bring down 2. Oops, again, draw your line here so that your remainder right here will be highlighted. So 2 times 2, 4. Negative 8 and 4 is negative 4. 2 times negative 4 will be negative 8. Add negative 2 and negative 8 to get negative 10. 2 times negative 10 is, no, is not that, negative 20. And then 5 and negative 20 is negative 15. Okay, so I have just determined that f of 2 is equal to negative 15. Nice and simple. Okay, so remember here, check if all terms are present. What do we notice in part B? I have x to the 5th plus x cubed plus 2x minus 15. Big giant hint here. We are missing the x squared term. I think I have to use the caret in my notes here. X squared, x to the 4th, and the x squared term. So when I do my synthetic substitution, and I'm going to evaluate part B here at negative 5 and 2. So negative 5, and I brought my coefficients, I have to remember, since we're missing these, use placeholders of 0 for those. Okay, so negative 5, there we go. So I'm going to put in my coefficients. I have 1, and then I have 0, and then I have 8 for x cubed, but 0 for x squared, 2 for the regular x, and negative 15. Okay, so let's draw in our little square. There's my factor. Here is my line that I'm going to use for my addition. And here is my line I'm going to use to separate my remainder. And I'm going to write in my work. So bring down your 1. Negative 5 and 1 is negative 5. Add those together, we get negative 5. Negative 5 and negative 5, that's positive 25. So 8 plus 25, I'm going to try and write a little smaller, is 33. 5 times 33, oh dear, we're getting small here, negative 165, which when I add to 0 is just negative 165. Negative 5 times negative 165 will give me positive 825. So then this will be 826 827. And when I multiply negative 5 times 827, I get negative, maybe, come on now, negative 4,135, oh my, go back, 35, which when I add them, I get negative 4,150. Looks like a G. 50. Okay, so I have used synthetic substitution to find out that f of negative 5 is negative 4,150. Okay, so we did negative 5. Let's do our 2 as well. Use the same numbers with the placeholders. 1, 0, 8, 0, 2, negative 15. Let me spread these out a little more actually, because we got a little tight last time. Alright, and put in my lines. My line for my synthetic substitution, my line to separate my remainder, and my box for my factor, for my A. Okay, bring down 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 8 plus 4 is 12. 2 times 12, 24. This brings down 24. 2 times 24 is 48. This is 50. When we add, 2 times 50 is 100. 100 minus 15 is 85. So there we go, my remainder, text f, hold on, of 2 equals, what did we say, 85. That's my answer down there. Okay, I'm going to stop the video and come back so that I have enough, short enough video I can put up on YouTube. I'll be right back.